Okay, we have video 4 in our series on statistics. When should we believe a statistical study? And these are some guide points you can use when you're watching the news or reading a newspaper, reading a magazine, and you see a statistical study presented. So these are just some things you keep in mind to see if this is information that you're going to consider valid to maybe inform your world viewpoint a bit, or if this is information that perhaps due to a poor study is really not worth taking very seriously. So the first thing we have is goal, population, sample, and type. You should be able to see what the goal of the study was. If the goal was to study, say, the effect of a nutrient on diabetics, then it's maybe not reasonable to generalize that to the effect of that same nutrient on athletes that are training for a sport. Yet we see this pretty frequently. A study will be done for a limited thing here, and then all of a sudden the news runs with it all over the place. So that would be a problem with the population and the goal. The goal was to study diabetics, the population was diabetics. We can't conclude to some other population then. So this would be one concern if you see a study where they're using the result to say something outside of the actual population they studied. Second one is the source. Who is paying for the study? You can find nutritional claims, take this and you'll add muscle, lose fat, sleep better, whatever, and lo and behold, at the bottom of the website, they're happy to sell you the product. Well, if the same people who are doing the study are selling it to you, they have a sort of built-in personal bias right offhand. They want you to buy their product. So they might even just be flat out lying. Maybe they did no study at all. Maybe this is just pure marketing. But even if they did a study, are you really going to trust people who have a biased interest in the answer coming up with a sort of fair answer? This gets us to a bit of a problem in the medical community, though, because if a new medicine is invented, who is going to study it? Of course, the company that has this medicine is the company that's going to want to study this medicine. Nobody else cares. But what a medical company is going to do is they're going to hire a research laboratory at a university to do a double-blind study of their medicine. So they hire ASU's Medical Research Department, and ASU has an Office of University Protocol for Studies that will attempt to make sure the study is done quite fairly, and the results will go to the people paying for it just like everybody else. Now you might wonder, they're still the source for the funding. Isn't that going to still influence the university? It's not impossible, but ASU has a very big interest in making sure that doesn't happen. Universities receive millions of dollars in studies, and if they're in the paper for being very, shall we say, dishonest in how they do a study to keep somebody happy, maybe that one customer is happy, but they just lost a lot of future business if that was their reputation. So universities have a guided and personal interest in keeping their reputation intact and doing studies honestly, even if it makes the individual client unhappy. So that's how we can get around issues in the source. Bias in sample. Really be careful that the sample represents the population we're talking about. For example, if especially in case control studies, certain people will pick a course of action, and that makes them different than the people who didn't pick the course of action. Maybe we're doing a study on back injuries, and the people who pick to have back surgery may have had worse back injuries than the people who say, no, I'll do more conservative treatment, I'll just do therapy. So we want to make sure that the sample represents the population in all of our relevant characteristics. And then this one comes up a lot in things you see online, like surveys or whatever, problems defining or measuring variables. For example, you'll see a question, what's more important in your life, love or money? Well, how are we going to measure that? How much love are you talking about giving me here, and how much money are we talking about? How do we compare? $0, I'm destitute, but I have all the love in the world? I mean, what are we actually talking about? Some questions are so vague, you could write them in a different way and get any answer you like. So those questions are they don't really mean anything. Then the third, what are we, 1, 2, 3, 4, I guess the fifth thing, confounding variables. Particularly in case control groups, case control studies, there can often be confounding variables. So you think you're measuring one thing, but in reality some other thing is interfering with your study. Famous study in a town in England. They did a longitudinal study, one of the first health longitudinal studies of its kind. And over 20 or 30 years, they found an interesting result. The smokers and non-smokers, the smokers had died, actually lived, more of them were alive than the non-smokers. So why were smokers, if you say 80% of them were still alive, and of the non-smokers, only 70%. So why would we have this kind of case? Why would there be more smokers alive after 20, 30 years than non-smokers? I mean, is smoking giving you a better chance of staying alive? Well, and that was one of the first results that came out of this study. The reason this was happening, this study was in post-World War II England in a small town. And young people tended to smoke more than older people. Smoking became very popular amongst the military in England during World War II. And older generations had lived through kind of the Great Depression, England's version of the Great Depression, and so they didn't take up things that just spent money they didn't have to do. So they didn't smoke as much. So the two groups were different based on age. We had a confounding variable of age. The smokers were younger. Turns out for living 20 or 30 years, it helps to be young. If you're already 90 years old in the non-smoker group, your odds of being alive in 30 years and being 120 are much less than a 25-year-old smoker who has to just live to 55. So the correlation here, the confounding variable messing up our correlation on smoking and longevity was age. Smokers were younger. So they have a very strong confounding variable. Readjusting their data to age balance the two groups, smokers were dying quicker. So it was merely the fact that age is a very important predictor of your likelihood of being alive in 30 years. It was messing up our data. And then the last thing, this is very often confused. Correlation does not prove cause, and it doesn't even prove which variable is causing which one if you're going to try and prove cause. So we're going to talk about correlation in the next statistics video. We're going to learn how to do correlations on our calculator, but we have to always keep in mind correlation is a mathematical relationship. We don't know which variable is causing which, or if some other variable we're not even thinking about. Hopefully we're trying to think of them, but we may not have realized a third variable, fourth variable, who knows, that we're not measuring is actually causing both of them. So we'll talk more about that in steps number 5. Thank you for watching this video.